Hi friends, so this is a eighth module on operations research. Very important because this course is on operation management, and that's why operation research becomes very critical to this course. So we are into our eighth module, that is operation research, and this is the last lecture of OR, that is operation research, that is PRA project management. Actually project management has a separate discipline in OR. For our course it would have been relevant if we discuss project management in the context of risk assessment project and PRA project, because my experience I wanted to share with you. So I am explaining the challenges that are there in the PRA project management and what we can tap from existing OR knowledge that is available to us. So let us start with this. If we look at a probabilistic risk assessment project, one of the biggest challenges, if we want to have a quality project, 20% of effort it goes into R&D. That means we have to be in touch with the R&D, and you should have these facilities around you. If you do not have it, we will not be able to do justice. For example, I will tell you, if I have some data with me and the data is weak or they are not good, then I have to do some live testing. So live testing should be available, and those knowledge base and the expertise that should be available, number one. Number two, if I have some component where I am not very confident or some assumptions, I am not sure about it, how it will impact my analysis, and that's why I should have advanced tools for uncertainty estimation and modeling in the way we want it, and sensitivity analysis. These tools should be there. So that means we have to develop those programs actually. Okay. Even representing our results, core image frequency and its impact, which is the last part of the PRA, that itself is very important. Now I have been talking about PRA project. What is the PRA project? So just this image I am showing you. The significance of PRA project is, it is one of the document that is available in the plant as an approved document, and which provides the basis for developing application as permitted by the regulator. Because as I said, quality of the PRA will determine its applications. Okay, that is number. And then so its significance is, it is very useful. But what is the size of this study? If I tell you this image I have taken just for say symbolic, a PRA project can be captured in let us say almost like 400 to 500 pages for a small plant, to a like a mega plant like power reactor and all, nuclear power plant, or chemical process plant, or it might go into more than 1500 pages, 5 volumes, 7 volumes, like that. So that means a lot of work goes into it, and comprehending those things and presenting the results, and then whatever insights that are available for PRA, or even without PRA, when you want to work at the level of the projects, it is very challenging to interrelate them. Like take the human resource. What should be the human resource that should be available, even though there are guides, experience that are available. Money, how much money should be, PRA is a very resource intensive activity. All these points should be there before we initiate development of project report. I feel this is one of the best thing that I did myself in my organization. When you develop a project report, what the project will do, what is required, what are the approval to be put up, and whether we should do it or not, because finally organization's clearance is required. So a project report is a very good interface between the analyst or a team to the organization, and then project evaluation occurs, regulatory clearances are there, and then you can initiate the project. But please assume that each PRA might take ranging from 2 years to 4 years, 5 years. Of course, some industries they are doing back to back some PRA from one plant to second plant to third. They might do it in 1 year, 1.5 years also, because they have the broad model that is available. Whatever changes they have to reflect in the same document, they can do it and test it and all that. But then if you do from scratch a PRA study for a typical representative case, it might take 4 to 5 years is my experience, number one. Number two, one of the major insight was 80% or 70% effort goes into data collection, analysis and elicitation. Why? Because data is very important. We can say this thing that if it is a junk going in it, junk only will come out. So data, and especially plant specific data. If we are not using plant specific data, let us say design stage, the data is not available, you can do it with the generic data, but then the it should reflect in uncertainty, and there should be a robust sensitivity analysis should be done to bring in impact of data, so that those efforts over the years can be implemented for collecting the plant specific data. Now, over project management, when we talk, the core activity is like consequence or financial evaluation. So it could be having a negative consequence, can be negative also. Consequences normally they are seen as a negative, but it can be positive also, improvement also. So in risk assessment, we focus on negative aspect, financial, hazard consequences and all that. So so that is where it becomes very important. One is we are deviating from the traditional approach to PRA approach, and second thing, you are getting into the data and all that. So quality of PRA is one of the very, and there are codes and guides, ASME guides that are available that will help us to understand the quality of the work. Let's say if in my project, if it is based on only 10% data, plant specific data, it was done. We understand the difficulty, but then it will reflect in quality of PSA. So my personal opinion is, if you want to give a quality PSA, at least 10 to 15 years of data should be available on the system, and if the data is not available there, wherever it is a impact is high, the live testing should be carried out. It will not tell the data correctly, but it will tell us to understand the robustness of the component that we are using, and then whatever vendor specifications are there, they can be converted into data. A PRA project for safety critical requires a multidisciplinary approach. As I mentioned, multidisciplinary approach means there will be design people, there will be operations people, there will be analysis for structural analysis, there will be analysis for electrical systems, electronic system, mechanical system. So for making a decision, you require a framework which suits this multidisciplinary approach. Okay. Yes, the data collection analysis is the core component I have explained to you, and this, to the extent possible, should not be compromised. If you are having some limitation, it should be brought out in the results, the limitation, and the suppose if you have made some assumption, now impact of that assumptions can be presented into the thing, and while declaring the results also, it can be told that there were so many assumptions. In the light of these assumptions, and impact analysis has been done, and the results are having these kind of connotations. Okay. PRA project management perspective is like planning. It is use planning, coordination, project prognosis, scheduling, data collection. All these things, components are there, along with the expertise, core team that should form, So it's a very complex project actually. But particularly if you are doing it for the first time, if you do it on routine basis, things become more simpler. You have trained people, you have plants which are having certain characteristics. They 90% the plant, one plant will be similar to other plants. So then the challenges drastically come down. But if you do it for the first time, it's a challenge. Then we should have a project management approach where technical, administrative, regulatory agencies, they should be working very closely. The challenge, there is hardly any reference available in open source on development of a PRA project. This is my publication. I felt the need of having this publication. So I am trying to explain what goes on into the PRA project and how it can be done with ease by having a system in place, permissions in place, okay, and data in place, all those things. So you can see this reference. It is available in one of the our society's NCRS 2022 conference as one of the expert talk. Now this is just symbolic. I should not have brought this. We do fault tree analysis, but the ecosystem is this only. Our efforts goes into developing this only. So PRA, one thing is it how the scope matters. Let's say if I do a PRA at level 1 with limited scope PRA. Limited scope PRA means no external event has been considered, only internal event with a hazard source identified, okay, and then human factor or uncertainty, technically what we are addressing, that becomes the scope. If it is a level 2, at least in nuclear parlance, if level 2, what is the scenario in containment, and if I do level 3, so these three things just understand like this. Most of the nuclear power plant world over, they have level 1 PRA. Now there is an increasing interest in level 2 PRA also, and some examples of level 3 PRA you will find, because as far as the plant operation is concerned, maximum benefit comes from level 1 PRA. This is there and now further the scope is expanding to include external hazard like seismic, flood and fire, and application specific requirements like emergency management in public domain. So this is all the scope, and our ecosystem is developing this fault tree, event tree, and this one. Now what are the procedural steps in level 1 PRA we have here. So now I am showing the chart here which is giving you project specific information, and here I am telling you what are the important steps that are available. If anybody is doing a PRA, they can have access to the IAE guide, but even if you don't do that, I am giving you development of project report. At least in my charter, this takes the top seat. After that only things start flowing, because the team start building up, management is supporting that, you have time availability, you have a mandate to do that thing. Then system familiarization. As I was mentioning in my AI module, the domain specific information is very important. If domain specific information is not there, or domain experts are not there, your PSA will be slightly different than what the model is. So the idea should be to reflect as built, as operated plant, and for that domain expert should be there. Hazard identification, then event tree, development of event tree, development of fault tree, data analysis and quantitative. So this is a technical thing. I will not go into the detail of it. I will say what are the project management issues. Resource allocation, you have a plant, you start the resource allocation, apex body, organizational team, they should give. So PRA project development happens, team is there. So their coordination with so many agencies, it happens in an integrated manner, charter, you have so many other teams, R&D team, data team and all, and then finally your project. So here we have technical element, here we have administrative element, because our topic is project management. Okay. Now if I want to bring efficiency or quality in my PRA model, what are the factors that affect the quality of PRA? Okay, what is the matrix? Okay, the leadership and management framework, then support. All sorts of supports are required. If it is not available, then it reflects into delays and difficulties. Information data availability. As I mentioned, data is very important, so a lot of effort goes into that. So there should be a lineup right from grassroots level, what kind of data that comes, how to filter it out, how to remove the outlier, and that, like for ANN we did pre-processing, post-processing, and then ANN takes. Same thing happens here also. If your data is not good, it will pay, we have to pay heavily. And qualified PRA software. Procuring, if you are doing for the first time, it is better to have a software and meet some expert, and in all this thing have some expert who is helping you in all this thing. Computational facility, human resource, very important, because this is what you have to fight it out for, and then you have to train them. Okay, guides and standards, they are very useful because they show us where are the walls, what are the references that are available that we can use. Even quality assurance documents are available, and regulatory expectations. You know what regulatory framework we have, whether there is a competency exists at the regulatory level. If not, they will hire some expert, but then initially these difficulties are, then each difficulty becomes a challenge actually. When design and engineering project operation are different compared to existing plant, since new plant will be different level of science, engineering. So there is a difference between new plant and the existing plant that we are doing, and that becomes a challenge actually, you know. You know, this is a Gantt chart actually. When we built the project schedule, each activity is given, and this activity has started here because it has a dependence on this completion of this activity. So like this, all those activities which I listed there, little bit here and there, they are here actually. And so the quality assurance activity, it goes through the all the activities of the plant. Okay, and then the documentation also at system level, at data level, system level, and at the plant level, it is a part of this document. So individually you can see that, and the best part of it is you are able to give that period, how long it will take for this project to complete. So this has been explained through the Gantt chart, which is part of project management activities and all that. Okay, and now we will study some advanced techniques or core techniques in OR, which can further help us to do rescheduling of the activities and all that. You might have heard of PERT CPM, Program Evaluation Review Technique and Critical Path Method. Now it is so happening, these two have been merged together, because in PERT, the thing I am explaining to you, even we are able to have a critical path analysis. So I will not give separate reference for PERT and CPM. I will tell either PERT or CPM or PERT only. So since the case study I am presenting it, I am not sort of trying to distinguish between these two terms. Okay, so you saw that all those events which I told you for PSA, that is required. Development of project report, system familiarization, hazard model, all those things have come here. This highlight doesn't mean anything, it's a part of, so development of event tree and fault tree, then its quantification will depend on data analysis and this thing. So each activity has been given some designation A, B, C, D, so that we can talk about it, and its a dependability also we have discussed. What we are saying is this event D will depend on C. This event E will depend on C. So we can say this is predecessor activity or dependability. These are the legends. ED means estimated duration. I am giving the duration in terms of months. So we saw that 45 months it takes, and the management want us to complete in certain time, let us say 2.5 or 2.5 years. So then we have a job line up, and here this particular matrix, it shows the speed of the PRA project, I would say. depends on what is your human resource that is available you, and of course expertise also, that is number one. And then how complex is the plant. The highly complex plant, it will take 6 years. If you have 7 person working with you, it will take 3 years. If there are 7.5 7.5 years, if there are 3 persons, and if you have 2%, so it becomes impossible, like 8 years it will take. By the time things would have changed. So what kind of allocation should be, human resource allocation should be done, depends on the complexity of the plant. Okay, if there is a plant with modest complexity, low complexity, let's leave it. So if it is so you should have 7 people if you have to complete the project in 3 years. Okay, so these are the things you can. And how this matrix has been developed, well, I will not say there is any mathematical computation that has been done. It is based on the in one of the IIA document, for one they didn't distinguish between complexity and all that, but they said this much manpower is required, and they had given backup. So those were the reference and my personal experience. So I have developed, but I think a couple of projects that I have done, I could get the sense that okay, how many people are required and how much is the time that mandates. If management says this plant is going to be started somewhere in 2 years, then I have to increase the manpower and I have to show them. This is the experience based, let us be experience based chart that we have over here, and these are all indicative. Okay, everybody can have their own experience and schedules. Okay, so now using this we have prepared this PERT CPM chart. Okay, PERT CPM chart, activity A is time for completion of project without uncertainty. Okay, these are the things I am explaining you, but A means project report, development of project report. This is activity. It takes 2 months developing a project report. Similarly, activity B. So you have to go to the previous chart, what these activities are lined, and my management has given me 2.5 years, that is 30 months. If I add up all these activities, it comes to 45, the total sum is 45. That means I don't have that, of course, we are there, we have done everything in sequence. So now through this chart, we are trying to have some parallel activities, so that how we can complete the project in a lesser time. So as I said, C, there are 3 activities, E, D and F, which depend on C. Okay, and then finally activity G depends on G. So here this is a node which identifies the event. This is the duration, node, activity and duration, node, activity and duration, and then there are some activities which has been shown can be performed in parallel, and then finally you join back here, and that's how up to last activity K, that is submission of the report which for the PRA. So we have adopted this particular chart, which is normally available in construction industries or in some plant building manufacturing ecosystem. Bridges being constructed, what is the progress, every day this chart has to be updated and all, but this we have used for our PRA project for 2 reasons. One, without PRA project report, there is no visibility what is going on in the project, how we are working, how far we are away from our target. So this is something like it provides a very open view of our work, and then suggestions we can, because many people are involved from outside project. So we can convince them your activity is coming in critical path. So this path. So we have to reduce it from 4 months to 2 months. So then they will also understand that other activities are not coming critical. So it becomes a very good mode of communication, not amongst ourselves, but even outside agency also. So having developed this chart, we have 3 paths. This path number 1, okay, path number 2 and path number 3. Okay. So now if I obtain the estimate, so path number 1 was A, B, C, D, G, I, J and finish. okay, and the durations was given. So it was giving 26 months. Start this one activity and all. So it was giving 34 months central path, and then this again another path to the right, it was giving 25. So now what is the critical path? Critical path is the longest duration thing. So why? Because we are trying to work on project. The activities which are going smoothly doesn't matter to us, but activities which are taking and it is resulting into higher project time is the critical path. So this 34 is the thing. Actually we were given 2.5 years time, and now we are having that means 30 months time, and we are taking more than 30 months time. So for 4 months what adjustment should be done, and discussion can be initiated, and probably this should be, then if this comes down, say let us say 30, then also it will remain on critical path. So that means these activities are not, path is not traveling, this is the only path we have to focus, and our job becomes much easier to have a project schedule in place. And finally we have to complete it in 2.5 years, that's it. So overview is diagnostic part. Okay, so here we are discussing the OR part. Probably this particular thing should not be there here because okay, and then the chapter is OR of the OR is one of the major topic in project management. A project management approach for PRA. We have used a thing which we can use it as a part of risk management for explaining the project activity. PERT CPM chart, we have seen how it benefits us in expediting our project, and at the same time maintaining quality of the project also. The approach discussed was did not consider random nature of variable. Okay, so I have explained you this chart by using the crisp value 2 months, 5 months and all that. But we know that uncertainty is part of everything. So it could be 2.5 months, it could be 1.5 months also. So that is where our probabilistic approach, it really gives you us, because before I commit to my management, I should be pretty sure that I will be able to do it. So sometimes I might do, there are optimistic mean value, optimistic value and pessimistic. Optimistic is the left of the distribution. So beta distribution we can use it. It was found very useful in this reference book that we have here. And pessimistic means what is the maximum time it will take, maximum upper bound. We call upper bound, we call mean and lower bound. So these estimates we use, assign the probability value, distribution, and we obtain 3 estimates. So while arguing in the board meeting, we can say I am pretty sure I will be completing in mean time, that is 34 months, but the pessimistic estimate will be around 50, or it could be 30 also. So I am giving between these two, and penalties can be handled by using this uncertainty type of estimates. And this book explains this thing, in because of time and paucity I could not bring it here. So if you are interested, please refer this book. It is available in open domain, and open the chapter on project management. Thank you.